Hello students, today we start class 9 number system. Class 9 number system. Children, you all know that what are the different types of numbers. In the earlier classes, we have learnt about different types of numbers. So, example, natural numbers, whole numbers, integers, etc. And also, you learned the properties of that numbers. Okay, now quickly recall those number systems. First number system is natural numbers. See, natural numbers. The name itself is says that the counting numbers are called natural numbers. Here, the counting numbers are called natural numbers. So, how do you count, children? So, whenever we ask you to find or count, then you will start with number 1, isn't it? So, we can count like 1, 2, 3, 4, 5 up to infinity. See? So, up to infinity. What do you mean by infinity? Infinity is a largest number. So, until that we have not count it. So, uncountable number or it's not founded. Not yet founded. So, natural number is denoted as a letter n. Okay. So, counting number is called natural number. So, next number system is whole numbers. Whole numbers. 0 and the natural numbers together called whole numbers. So, what are whole numbers? So, here in the natural numbers, so only start from 1 and end with infinity. Whereas in whole numbers, you can see 0 is added to the system of natural numbers. So, look at that. This is also extends up to infinity. So, there is no largest whole number. Okay. So, next type of number is integers. Children, integers are the numbers you might have come across negative numbers. You might have come across in a different situations like opposite direction, going into the depth of the sea and going the temperature of some city, for example, temperature of Delhi, winter season, and temperature of Antarctica. So all these things represent it will be in the minus degree centigrade. So negative means minus. So negative means minus. So negative numbers and positive numbers, see, whole numbers. So negative numbers and the whole numbers are called integers. You can see integers can be denoted as a letter Z. So this is a pattern of integer, 0 in the middle. So on the right hand side of the 0, you will get positive numbers, and the left hand side of the 0, you will get negative numbers. 0, 1, 2, 3, 0, minus 1, minus 2, minus 3. This integer number system also extends up to infinity. Okay, next number is rational number. So what do you mean by rational number? So in class 8, you learned about rational number, right? So any number, the number which can be expressed in the form of p by q, where p and q are integers. See, the numbers which can be expressed in the form of p by q, where p and q are integers and q should not be equal to 0. So this type of numbers are called rational number. Example, you can see here 2 by 3. 2 by 3 is a rational number. So 1 minus 1 by 8 is a rational number because it is expressed in the form of p by q. Minus 3 is a rational number. 0 0.5, 0. All these things are rational number. Why it is rational number? 2 by 3. 2 is a numerator, 3 is a denominator. P by Q. So here minus 1 is a numerator, 8 is a denominator. Here minus 3 is a numerator. Denominator is nothing is there, you should take as 1. So it is also in the form of P by Q. So 0 0.5 can be written as 0.5 can be written as what? 5 by 10. 5 by 10. 0 can be written as 0 by 1. So that's why these are all example of rational numbers. So that you have learned in a class 8. Okay, next type of number is irrational numbers. What are irrational numbers? Irrational numbers are the numbers which cannot be expressed in the form of p by q. So what are irrational numbers? The numbers which cannot be expressed in the form of p by q. Now you can see here we are not express this in the form of p by q. Okay, we can also say non-terminating and non-recurring decimals are known as irrational numbers. Okay, see here, non-terminating and non-recurring decimals are known as irrational number. Example, root 2, root 3, root 15, pi, 1.01001001, like that. So this is called irrational number. Further, we'll go to how it is irrational number. We'll see that. Write the decimal expansion of the following numbers. Now, all of you know that it is decimal expansion. Now, you can see here the decimal expansion of 1 by 2. So, you know that 1 by 2 is a rational number. So, when we divide 1 by 2, you will get 0.5. So, 0.5. So, this is terminated decimal. This is terminated decimal. The next number is 1 by 8. This is also a rational number. See here. So, when we divide this, you will get 8. So 8 ones are 0.1, 20. So 8 twos are 16, then 40, 8 fives are 40. So the remainder is 0. Whenever the remainder is 0 comes, and that is terminated decimal. This is called terminated decimal. Okay, so let us see another example. 1 by 3. So when you divide 1 by 3, so 3, 10 divided by 3, and you can see here 3 3 is a 9, 3 3 is a 9. So 1 is remained, again 3 3 is a 9, again 3 3 is a 9. So it is repeating. The number 3 is repeating many a times, and this is called recurring decimal. This is called recurring decimal. This 0.3 bar indicates that the number itself is repeating many a times. So non-terminated, this is called non-terminated. See, until that we got terminated, so we got remainder 0, but here we are not getting remainder 0. This will be continue for a long time, so that's why it is non-terminating and recurring. So recurring decimals are like this. Okay, so now we'll take another example. 1 by 7. So when you divide 1 by 7, you will see that 0.142857, 142857. So you can see here these numbers are repeated itself after long decimal. So it repeats again. So this is also called recurring deposit. See, recurring 0.142857. So this is recurring non-terminated. So because it will continue for a long time, so that's why it is called non-terminated. So let us see other examples. Pi. You might have known that pi is, it will be used for area of circle. So this is a constant. Pi is a constant, and this can be written as 22 by 7. So we know that what is 22 value of 22 by 7. See, the value of pi 3.1415926535897, etc. It will go on like this. And the value of root 2 is 1.414213562373. So if it is go like this, and these type of numbers are called irrational numbers. So why this is irrational numbers? This is, first of all, this is non-recurring, non-terminating, non-recurring and non-terminating. Why it is non-recurring? Because these numbers are not repeated. So these numbers are not repeated. That's why it is non-recurring, and this will continue. So it never ends. That's why it is non-terminated. So now how we can say the irrational number? What are irrational numbers? Irrational numbers are non-terminating and non-recurring decimals. So what are irrational numbers? Irrational numbers are non-terminated and non-recurring decimals. Such numbers are called irrational numbers. Got it? So you already know that all the types of numbers: natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Now we'll ask some questions to answer. So what are rational numbers? So what are rational number? So rational numbers are the numbers which can be expressed in the form of p by q. Okay. So another question: every whole number is a not no, every whole number is a natural number. Can we say this? Every whole number is a natural number? No. Is it true or no? Because zero is there. Zero is not there in the natural number. So that's why we cannot say this is a false. And what are irrational numbers? What are irrational numbers? Now only we said that. So non-terminating and non-recurring decimals are called irrational number. Example: pi, root 2, root 3, etc. All root numbers, for example. So root 4 is not, because you will get the value 2. So that's why it is rational number. So you understood what are rational now and irrational numbers. Now let us find rational numbers between any two rational numbers. Now what you are doing, so we have to find rational numbers between any two rational numbers. Okay, first question: find the rational numbers between 1 and 2. Find the rational number between 1 and 2. So how many rational numbers you have to find? 5 rational number. Any 5 rational number. Okay, so we'll find any 5 rational number. So in order to find this rational number, first let us draw a number line. Let us draw number line. So this is a number line. Okay, you can see here. So this is a number line of 1 and 2. So in between, so number line 1 and 2, and between the 1 and 2 there are some points. Can you observe that points between 1 and 2? You can see that points. So these are the rational numbers between 1 and 2. So 9 by 8, 5 by 4, 3 by 2, 7 by 4, 7 by 4, 9 by 8, 5 by 4, 3 by 2, 7 by 4. So these are the rational number between 1 and 2. Okay, we use the formula. Now we need to find the rational number between 1 and 2. So use the formula a plus b by 2. A plus b by 2. That we are finding the midpoint of 1 and 2. So here what we are doing, we are finding the midpoint. Okay, now let us take a is equal to 1, b is equal to 2. So substitute the value for a plus b by 2. So here the value of a is 1, value of b is 2 divided by 2. So when we just take this, and the value will get 3 by 2. So 3 by 2. When you add 1 and 2, you will get 3 by 2. Got it? So okay, this is a one rational number between 1 and 2. One rational, we already we have shown here one rational between 1 and 2. Then the next one, now if between 1 and 3 by 2. So between 1 and 3 by 2. So what is the rational number? We will get, we will see. Let us take a is equal to 1, b is equal to 3 by 2. So what is the formula? A plus b by 2. A plus b by 2. So implies that, so instead of a 1, instead of b 3 by 2, so the remaining 2 will be here. And now take the LCM. See, this, as this is a fraction, so we need to take LCM to add this number. Take the LCM. 2 plus 3 by 2 by 2. 2 plus 3 by 2 by 2. Okay, so what is 2 plus 3 is 5. 2 plus 3 is 5, and 2 into 2. So we can write this is 2 into 2. So now this becomes 5 by 4. This becomes 5 by 4. Okay, so 5 by 4 is one of the rational numbers for that. Again, we can take between 3 by 2 and 2. We can also take between 3 by 2 and 2. So what is the formula? A plus b divided by 2. So 3 by 2 plus 2 divided by 2. That is equal to 3 plus 4 by 2 by 2. That is equal to 7 by 4. So 7 by 4 is also a rational number. So how many rational numbers found out? 3 rational numbers. Now we'll go to the next rational number. The same formula you are going to use it here. Now between 1 and 5 by 4, you can take any number. You can take between any the given numbers. You can take, no problem. So a plus b divided by 2. 1 plus 5 by 4 by 2. So 5 by 4 by 4 by 2. So you're taking LCM here. So LCM 1 plus 5 by 4, 4 by 5 divided by 4 by 2. So this can be written as 9 by 4 into 2, that is 9 by 8. 9 by 8 is another rational number between these two. Now let us take another rational number now between 7 by 4 and 2. So between 1 and 2 only we are taking. So fraction, the various fractions are vary. Look at here, a plus b divided by 2. So 7 by 4 plus 2 by 2. So this becomes, take the LCM now. 7 plus 8 divided by 4 by 2. So 15, 4 into 2, that is equal to 15 by 8. See, so we get 5 rational numbers. Now let us see how are the rational numbers. The 5 rational numbers between the rational numbers are 3 by 2. Can you see here? So 3 by 2, 5 by 4, 7 by 4, 9 by 8, 15 by 8. So these are the 5 rational numbers between 1 and 2. Okay. Okay. Now we'll have another method, alternate method. So this is a one method now which we have solved. Another method, how we are going to do it, it's very easy method. You can use any of these two methods. Okay. Okay, let us see. Let us take the number 1 and 2. Now we have to find the rational number between 1 and 2. So write 1 and 2 as a rational numbers as a denominator as 6. Why we are going to write 6? Because we need to find 5 rational numbers, and 5 plus 1 is equal to 6. Denominator should be 6. Okay, now what you have to do is multiply both numerator and denominator by 6, and here 6, and you will get number. See, 1 can be written as 6 by 6, 2 can be written as 12 by 6, because the denominator is same. Okay, so now it is very easy now to find the rational number, because in between 6 by 6, 12 by 6, you will have this number. Okay, 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. See, this is a rational number between 1 and 2. So this is very easy method, right? So you can follow either of any method. So any method is also. Now we'll come to exercise 1.1. So exercise 1.1 in your book. So look at that. We will read the question. What is the question? 0 is a rational number. 0, first question. 0 is a rational number. Can you write it in the form of p by q? P and q are integers, and q should not be equal to 0. 0 is a rational number. 0 is a rational number. Can you write it in the form of p by q? Write it in the form of p by q. Okay, now we'll say that yes, 0 can be written as in the form of p by q. P by q, 0 by 1. So 0 can be written as 0 by 1. Now it is in the form of p by q. Q should not be equal to 0. It is a rational number, right? 0 is a rational number. This can be written as 0 by 1. Okay, now this is the first question. Second question. Find the 6 rational numbers between 3 and 4. Now the second question is find the 6 rational numbers between 3 and 4. Okay, so now we can use any of the method. So look at that, a plus b by 2. So the first method only will take a plus b by 2. So here, so number a is 3 and b is 4. 3 plus 4 by 2, that is equal to 7 by 2. This is the one rational number. Again we'll take another number, 3 and 7 by 2. Between 3 and 7 by 2, how we can write? 3 plus 7 by 2 divided by 2, and take LCM. 3 2s are 6, plus 7 divided by 2 into 2. So that 7 plus 6 is 13. 2 into 2 is 4. 13 by 4. This is another rational number. Take between any two rational number. Now 7 by 2, 4. So 2 4s are 8. 7 plus 8 is 15 divided by 2 by 2. Here 15 2 into 2. 15 2 into 2 means 4. 15 by 4. 15 by 4 is also a rational number. Like this, you can find many rational number between 3 and 4. Many rational number between 3 and 4. Okay. Okay, next we'll move on to the next problem. Third problem. Right, find the 5 irrational number. Find the 5 rational number between 3 by 5 and 4 by 5. Between 3 by 5 and 4 by 5. Now we can follow is another method, alternative method, that what we are discussed. Now let us write 3 by 5 multiply by 6. Why we are multiplying 6? Because we need to get 5 rational numbers. For that, it should be denominator should be one more than 5, one more than 5. Look at this, 3 by 5 into 6 into 6, both numerator and denominator. 4 by 5 6 into 6. So write this number. Now you can see 6 3s as 18 by 30, 69 18 by 30, and this is 6 4s are 24 by 30. So these two are the same denominator. Between this you can see the number. Okay. What are the number? 19 by 30, 20 by 30, 21 by 10, 22 by 30, 23 by 20, 30. Okay. So this is a rational numbers between 3 by 5 and 4 by 5. So you can see the rational number. So between 18 by 30, 25 by 30, there are 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. Okay. So okay, let's take the homework. So homework is which is the least whole number? Which is the least whole number? Now you should find out. Is 23 is a rational number? Is 23 is a rational number? Find the 5 rational number between any two rational numbers. Any two rational numbers. Okay. Got it? So you know how to find a rational number between any two rational number. You have got two methods. You need to find the rational number. Quickly recall that. So what we have learnt. So natural numbers. What is natural number? What is natural number? Natural numbers are the numbers. Natural numbers are the numbers. Counting numbers. They are called also counting numbers. So this can be denoted as n is equal to 1, 2, 3, 4 up to infinity. Infinity means so largest natural number. We don't know what is the largest natural number till we have not counted it, isn't it? So whole numbers. What are whole numbers? 0 and the natural numbers together called whole numbers. Okay. So when you add 0 to the system of natural number, you will get whole number. Okay, we start from 0 and end with infinity. Okay, integers. Integers are negative numbers. Especially we are getting negative numbers and the whole numbers together called integers. You can see here 0. On the left hand side of the 0 you will see negative numbers, and the right hand side of the you will see positive numbers. Okay, middle there is a 0, and you can see here rational number. What are rational numbers? Rational numbers are the numbers which can be expressed in the form of p by q, where p and q are integers and q should not be equal to 0. This should be remembered. Okay, so the examples are given: 2 by 3, minus 1 by 8, minus 3, 0.5, 0. So why it is rational number explained below. Okay, next, what is that? Irrational numbers. So what are irrational numbers? The numbers which cannot be expressed in the form of p by q. No. So the numbers which can be expressed in the form of p by q is rational number, which cannot be expressed in the form of p by q is irrational number. So non-terminating and non-recurring decimals are known as irrational number. So now what is non-terminating and what is non-recurring, you understood. So example for irrational number: root 2, root 3, root 5, pi, etc. All these things are example of no. Now we'll see which are the decimals which terminates, which are the decimals which non-terminate, which are the decimals with recurring, which are the decimals with non-recurring. So first decimal you can see here 1 by 2. 1 by 2 can be terminated because the answer is 0.5. So the no other number is repeated or continued after 5. So that's why it is terminated. Okay, the next number is 1 by 8. See, 1 by 8 also you get the answer 0.125. 125. 0.125 is not term. It is terminated. It is terminated, right? It is terminated. And next number is 1 by 3. Look at this special number 1 by 3. So 1 by 3 you can see 10. So 3 3s are 9. So you will get remainder 1 and add 0, and then again this process is continued, and 0.333333. So repeated number also called recurring numbers. Repeated numbers also called recurring number. 0.3, the bar indicates that recurring number. So this number 3 is repeating. The bar indicates that 3 is repeating. So this is also non-terminated. The special thing is non-terminated. Non-terminated, it will continue. So however you are doing it, it will be continued. That's why it is non-terminated. Okay, next number is 1 by 7. 1 by 7 is also rational number, because you can see here 0.14285.7. After that again it repeats 142857, like this. This will repeat for a long time, so and repeats itself. So that's why we can see the repeated numbers. What are the repeated numbers? 0.142857. Okay, this is called repeated number. This is recurring and non-terminated. Recurring and non-terminated. Now we'll come to the next number. So these are irrational numbers. These are the example of irrational. Why it is irrational number? Because this is non-terminated and non-recurring. It is not recurring. See, all numbers are different after the points. Here 2, root 2. Also you can take root 2. All numbers are different. So it is non-recurring, non-terminating decimal. Non-terminating and non-recurring decimals are called irrational numbers. Okay, so irrational numbers. Now we can what are the rational number? Every whole number is a natural number. True or false? What are irrational numbers? You answered it. Okay, next. So represent. Now let us find the rational number between any two rational number, so that you understood. Find the rational number between 1 and 2. So any 5 rational numbers you should write. First method is, see, this is how you can represent the rational number on the number line. You can see 1 and 2. Between 1 and 2 there are many rational numbers that we have found out. How we are finding out? We are finding the midpoint of that 1 and 2. So the formula for finding rational number. So a plus b divided by 2. This is the formula. Use the formula. You know that a is equal to 1, b is equal to 2. So substitute a and b. 1 plus 2. 1 plus 2 divided by 2. 1 plus 2 divided by 2 means 3 by 2. 1 plus 2 divided by is 3 by 2. So 3 by 2 is one of the rational number. Now let us take another rational. Now between 1 and 3 by 2. A is equal to 1, b is equal to 3 by 2. Now again you can see that. So 1 plus 3 by 2 by 2 and 2 plus 3 by 2 by 2. So 5 by 2 into 2, that is equal to 5 by 4. So that is one of the rational number. Another rational number you can see here. So a plus b by 2, 3 by 2 plus 2 divided by 2, 3 plus 4 by 2 by 2, 7, 2 into 2, 7 by 4. So this is how you can find the rational number between any two rational number. Okay, the second method you can see that. So what you are going to do in the second method, make the denominator is same. So like how many numbers you want to find, so add that number and you will get more number. 5 plus 1 is equal to 6. Now it should be, denominator should be 6. So 1 can be written as 6 by 6, 2 can be written as 12 by 6. Now between this number you can easily find out 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. So this is the rational numbers between any two rational numbers. Okay, so we have found out exercise 1.1 we have done. So homework also given. Fourth problem. So exercise 1.1 fourth problem, you can see here. State the following statement, true or false. Give reasons. Every rational number is a whole number. It's true, because every natural number is a whole number, because so natural numbers is included in the whole number. That's why after 0 natural number comes. That's why it is true. Now look at that. Every integer is a whole number. False, because -3 -2 is our whole number. are not whole numbers. Look at minus 3, not whole number. They are not whole number, right? They are not whole numbers. Every rational number is a whole number. 3 by 2 is not a whole number. 3 by 2 is not a whole number. So that is a false. It is false, false, true. So, okay. Thank you.